Okay, so before we get into simplifying rational expressions, we need to review what it is to find a least common denominator. So a common denominator is any number that both the denominators will divide into. So you can't be smaller than either one of the numbers, because if it were smaller than 21, 21 won't go into it. So it's got to be at least as big as the both numbers. It could be the bigger number, but not always. And in this case, you can see it's not going to work because 14 doesn't go into 21. A common denominator will always be 14 times 21, or the denominators multiplied together, but that wouldn't be the least common denominator necessarily. So that's the trick, is finding the least common denominator. There are a couple of ways to go about this. You could write down what 14 is. 14 is 2 times 7, so those are 14's factors. And 21 is 3 times 7, so those are 21's factors. And so the least common denominator is a number that both 14 and 21 will divide into, and so you need to collect all the factors for each number. The trick is to make it a least common denominator. You don't want to repeat the number. So if I circle these 7's, I just have to write the 7 down once. And then 14 has a 2, so I would need to write that 2 down. And 21 has a 3, so I would need to write that 3 down. And so the LCD of 14 and 21 is 7 times 6, or 42. Another way to do it is to take the smaller number, and start multiplying. 14 times 1 is 14. 21 doesn't go into 14. 14 times 2 is 28. 21 doesn't go into 28. 14 times 3, that's 42. 21 goes into 42. So that's another way to find the LCD. The second one, 210 and 630, the LCD, if we write down 210's factors and 630's factors, well, we know they both have a 10, so you don't have to write the prime factorization, you just have to factor it. And once we know that they both have a 10 in common, we know that the LCD is going to have a 10. And then 21 is 3 times 7, and 63 is 3 times 21, which is 3 times 7. So we've already written down the 10. We would need to write down a 3. They both have a 7, so we would write down the 7. And then 630 has a 3, so we would need to write that down. So the LCD for this one turns out to be 30 times 21, which is 630. So in this case, the LCD was the bigger number, and that's where this technique of take the smaller number, multiply it by 1, 210. 630 doesn't go into 210. Multiply it by 2. 210 times 2 is 420. 630 doesn't go into 420. 210 times 3, that's 630. And so you found your LCD. Okay, you can also do it for 3 numbers. The LCD of 15, 10, and 2. So 15 is 3 times 5. And 10 is 2 times 5, and 2 is obviously just 2. 2 times 1, we don't need the 1. So the LCD would be, none of them have all 3 at the same time. So you would need a 2 for these 2. You would need a 5 for these 2, and then you would need a 3. So the LCD here would be 10 times 3, which is 30. Or you can take the smallest number. 2 times 5 is 10. I skipped 1, 2, 3, and 4. But 15 doesn't go into 10. 2 times 6? No. 2 times 7? No. 2 times 8? No. 2 times 9? No. 2 times 10? No. 2 times 11, 12, 13, 14. 2 times 15 is finally the first number that goes into both 10 and 15, as well as 2. Okay, what's this for? Well, the reason we're doing this is because we're going to be adding rational expressions. So first we need to learn how to add regular fractions, or just review it. And so when you're adding fractions, you need a common denominator. So the common denominator of 12 and 15, if you want to do the small number, keep multiplying, 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 you'll find it. Or we can just do it this way. 12 is 2 times 6, which is 2 times 3. So 12 is 2 times 2 times 3. 15 is just 3 times 5. So the LCD would be, they both have a 3, and then this one needs a 2, and another 2, and then this one needs a 5. So the LCD of this one would be 6 times 10, which is 60. If you did the multiply the small number by 1, by 2, by 3, by 4, by 5, 12 times 5 is 60. 15 goes into 60. Okay, so the LCD is 60, but we can't just change the LCD, the denominators. We have to remember that we can't change the ratio. So now our thinking is going to change, and we're going to have to multiply both of these fractions by what I call a convenient form of 1. So I want 12 to turn into 60 with the use of multiplication. So I could multiply the 12 by 5 and get 60, but I have to also multiply the numerator by 5, because that's 1, and that's okay. You can multiply anything by 1 and not change the value. So for this 15, there's 13 over 15 here. 15 I would multiply by 4. Well, I have to also multiply the top by 4. So that's legal. I did not change the ratio of each of those fractions. So that's going to give me negative 5 over 60 plus 13 times 4, that's 52 over 60. And then I'm going to add, using my addition rules, negative 5 plus 52 is a positive 47 over 60. Okay, so now we are ready to look at some variables. And so number 1 here, find the least common denominator of the following rational expressions. Hopefully we know by now factoring is our friend, and all of these things up here were factors, written as a product. And so your first step is to try to factor the denominators. Okay, so you cannot do this until you factor, and so you have to be good at factoring and good at factoring completely. So this quadratic trinomial, if it factors, it's going to factor into x and x. The factors of 20 that subtract to be 1 would be positive 5 and negative 4. And x squared minus 25 is a difference of 2 squares, so that's going to factor into x plus 5, x minus 5. Now we want to get a least common denominator, and so the good thing about doing this is we don't have to write the factors. We can just look at them, and so the LCD is going to be a collection of factors. If they repeat, you don't write them twice. So what we can see is that each of these denominators has an x plus 5, so you write that down once. This one has an x minus 4, so you would write that one down, and this one has an x minus 5. So this is the LCD of problem number 1. Okay, problem number 2, 4x over 6x plus 15. You have to always be on the lookout for a greatest common factor. So 3 goes into both 6 and 15, so this is going to be 3 times 2x plus 5. And x plus 4 over 4x squared plus 10x, there is a 2 that goes into both 4 and 10. There's also an x. This is x squared and this is x, so you could pull out a 2 and an x. And then 4x squared divided by 2x is 2x, and 10x divided by 2x is just positive 5. So first step is to factor your denominator, and then your LCD is going to be a collection of all the factors. Well, this one has a 3, so you would need a 3. This one has a 2, so you need a 2. This one has an x, so you would need an x, and they both have a 2x plus 5, so you would need a 2x plus 5. So your LCD for this one is 6x times 2x plus 5. Okay, again, you can also do this for more than 2. So again, first step, you would want to factor. 3 over x plus 6 doesn't need to be factored. X plus 5 over x squared minus 3x. Again, there's an x in common. So you pull the x out and you're left with x minus 3. And x cubed over x squared plus 3x minus 18, that factors into two binomials, x, and then what are the factors of 18 that subtract to be 3? That's positive 6 and negative 3. And so our LCD is going to be a collection of all the factors. And so this one has an x plus 6, and this one has an x plus 6. So we need that in our LCD. And then this one has an x, so you would need that, and I'll put it in the front. And then this one and this one has an x minus 3, so you would need that. And so this is the LCD. It is the factor that all three of these denominators would divide into nicely. Okay, so now we're going to move back to the purpose of all this is to be able to add and subtract rational expressions. Okay, so what we want to do is we just want to change things just a little bit. We're not going to write the LCD in a separate spot. We're just going to get an LCD. And so when I have variable factors in the bottom, I kind of change the question around. I'm going to rewrite this with room to multiply by a convenient form of 1 on either side of the fraction. Because remember, that's what we need to do in order to add fractions. We can't change the ratio of the fraction, but we can multiply by 1, and we can change the look of 1. Alright, so the question that I ask is going to change, but hopefully our work is going to help you understand why I'm asking this. I look at my two fractions, denominators, and I say, well, what does this have in its denominator that that one needs? So this has an x plus 8, and that has an x minus 5, and these are not alike at all. Even though they both have an x in common, they're not alike at all. You can't use addition. You have to use multiplication. So this factor x plus 8 is needed over here. So I'm going to multiply this fraction by x plus 8 over x plus 8. And then what does this fraction need that this one has? This fraction has an x minus 5 factor. So this one needs an x minus 5, and I'll multiply by x minus 5 over x minus 5. That's what I call a convenient form of 1. And now what you want to do is your objective is to add the two fractions together. So you know you only add the numerators together. We have a common denominator of x plus 8 and x minus 5. So what you have to do is distribute and multiply out the numerator. But you never, ever, ever, ever need to multiply out the denominator. You can leave the denominator in factored form. It won't do you any good to multiply it out. But you have to multiply out the numerator. So this would be 7x plus 56 over, don't multiply it out, x plus 8 times x minus 5. Plus, and then this one would be 2x minus 10 over x plus 8, x minus 5. And so now we're adding two fractions that have a common denominator, so you would add like terms. That's why you have to multiply the top out. So 7x plus 2x is 9x, and 56 plus a negative 10 is 46 positive over x plus 8, x minus 5. And then you would want to take a look at your, now you have one fraction by the way, and it says simplify, so you want to take a look and see if you can just factor anything out of here. Because if you can, it might create a factor that can cancel. But in this case, there's nothing that goes into 9 that also goes into 46, so we know we're done. Alright, let's try another one. This one just has numbers on the bottom, but you can do the same kind of thinking. I'm going to rewrite the fractions and give myself room to multiply by a convenient form of 1. I have to get a common denominator. And so I know that 10 is 5 times 2. So if you want to think about it this way, this 5 needs a 2 over 2. This 10 doesn't need anything. It's already got a 5 in it. So you don't need to multiply that one by anything. Okay, again, we're going to distribute. So this is a grouping symbol. This division symbol, it horizontally written is understood to be a grouping symbol. So when we multiply, we got to make sure we distribute the 2 to both terms. So that's 2p plus 12 over 2 times 5, which is 10, plus p plus 1 over 10. Now we have two fractions with a common denominator. We add like terms. That's 3p plus 13 over 10. Remember, you don't add the denominator. You just bring the common denominator down. And there's nothing that factors out here. All right, let's move on to another problem. So we have 4x over x plus 2 plus 7y over y plus 2, and we want to multiply by a convenient form of 1 to get a common denominator. So these are not alike at all. It doesn't matter that they both have a plus 2. They are completely different factors. So this x plus 2 denominator would need a y plus 2 denominator, and you multiply by a convenient form of 1 because you do not want to change the ratio of the fraction. And this y plus 2 needs an x plus 2, so we're going to multiply by x plus 2 over x plus 2. And then we're going to distribute this 4x into both of those terms, so that's 4xy plus 8x over y plus 2 times x plus 2. You don't have to multiply out the denominator. And then 7y times x is 7xy plus 14y over y plus 2, x plus 2. And we have a common denominator, so now we're going to add like terms. So 4xy plus 7xy is 11xy, and then 8x doesn't have a like term, so plus 8x, and then 14y doesn't have a like term, so 14y, and you have the denominator y plus 2x plus 2. Okay, and then the last one here, 5x over x minus 2 plus 2 over x minus 1, we need to multiply by a convenient form of 1. These are not the same factor at all. They're not related at all. So this factor x minus 1 is needed over here. And what does this one need that one has? Well, it needs an x minus 2 over x minus 2. And I'm going to put parentheses around it because I want to remember that I've got to distribute. So 5x times x is 5x squared, and then minus 5x over x minus 1, x minus 2, plus 2x minus 4 over x minus 1, x minus 2. Add like terms, so we have 5x squared, negative 5x plus 2x is negative 3x, and then a negative 4 over x minus 1, x minus 2. Now we've created a quadratic trinomial, so I need to try to factor that, because what if it has an x minus 1 and an x minus 2 in there? A quick way to do that is the discriminant, b squared minus 4ac. So if I type in negative 3 squared, which is 9, minus 4 times a, which is 5, times c, which is negative 4, I get 89, and that's not a perfect square, so I know that doesn't factor. But I checked. Okay, so let's look at subtraction now, and I have a little trick that some teachers may not even endorse, but I have seen enough people forget to distribute a negative that it's what I choose to show people to do. And that is, when you're subtracting, we just learned how to add. I always change subtraction to adding the opposite. So 5 over x minus 2 minus 7 over x minus 5 is equivalent to 5 over x plus 2 plus a negative 7 over x minus 5. When you do that, you don't distribute the negative to both the numerator and denominator, because a negative over a negative is a positive, and that's not what we want to do. We don't want to change the problem. So we would only distribute this negative to the numerator. Okay, so then it becomes the same thing we've been doing up there. What does this one have in its denominator that this one needs? Well, it needs an x minus 5. So I'm going to multiply both sides over here by x minus 5. And over here we would need an x plus 2 over x plus 2. So if I distribute, I'm going to get 5x minus 25 over x minus 5 times x plus 2 plus, now we have to be careful, a negative 7 being distributed to both of those would be a negative 7x minus 14 over x minus 5, x plus 2. Add like terms, 5x plus a negative 7x is negative 2x. Negative 25 plus a negative 14 is negative 39. And there's your simplified rational expression. And we know we can't factor that in anymore. All right, this time, this is really where we want to pay attention. So we're going to subtract this rational expression here. First of all, I like this problem. It allows me a chance to say, can you divide out the 6x's? The answer to that is a resounding no, because this horizontal fraction bar is a grouping symbol. And so these are kind of stuck together. You have to add these two together before you could ever consider dividing. And of course, they don't add together because they're not like terms, but you cannot divide out the 6x over 6x. Okay, so first thing I'm going to do is change my subtraction to adding the opposite, and it's a little bit more involved than the last example because parentheses hopefully will help you see this. This minus belongs to both of these. So when I change this minus to adding the opposite, this minus changes to a plus, and this 6x becomes a negative 6x. This 1 becomes a negative 1. And remember, don't distribute the negative to both the numerator and the denominator, because that would make it a positive. You just distribute the negative to the top. Okay, so now I'm ready to find my common denominator by saying, what does this have as a factor in it, in the denominator, that this one needs? These are not alike at all. So this one would need a 6x plus 5 over 6x plus 5. And I'm going to put parentheses around everything. And then this one has an x plus 3 in its denominator, so this one would need an x plus 3 in its denominator. And so now I have to actually FOIL this out. 6x times x is 6x squared. 6x times a negative 4 is negative 24x. 5 times x is positive 5x. Positive 5 times negative 4 is negative 20 over 6x plus 5, x plus 3. Plus, parentheses around that, negative 6 times positive x is negative 6x squared. Negative 6 times positive 3 is negative 18x. Negative 1 times x is negative 1x. Negative 1 times 3 is negative 3 over 6x plus 5 over x plus 3. So now I need to add like terms since we have common denominators. 6x squared plus a negative 6x squared cancels. Negative 24x plus 5, that's negative 19, minus 18x minus 1x. I might use my calculator here so I don't make an error. Okay, so we have negative 24x plus 5x minus 18x minus 1x. And that gives me a negative 38x. Okay, can cross those out. And then I have a negative 20 and a negative 3 to add together. That's negative 23. And then the denominator would be 6x plus 5, x plus 3. Check to see if this factors in. It does not. So there you go. Okay, 2 more to go just to practice a little bit. This will be 4x over x minus 2, and I'm going to need to multiply it by something. I'm going to change this minus to adding the opposite. So this is a grouping symbol. This minus is going to go to both of those. So that's plus negative x minus 2 over 4x. Okay, so this time this is two factors. 4x is not really stuck together. That's 4 times x. So there's a factor of 4 that this one would need, and there's an x that this one would need. So I am going to multiply by 4x over 4x. This one has an x minus 2 in it that this one needs, so I'm going to multiply by x minus 2 over x minus 2. So then I'm going to multiply 4x times 4x, that's 16x squared, over that, 4x times x minus 2, plus negative x times x is negative x squared. Negative x times negative 2 is positive 2x. Negative x times x is negative 2x. And negative 2 times negative 2 is positive 4. And over here, down here, we've got 4x times x minus 2. Add like terms. 16x squared minus x squared is 15x squared. 2x minus 2x cancels. Plus 4 over 4x times x minus 2. This does not factor, so you can't factor anything out, and you certainly can't cancel this plus 4 with that 4. This is stuck together like glue. You can only cancel after you factor. And this is not factorable, so that's your final answer. Okay, so the last problem, I changed it a little bit. You should be seeing 4m plus 1 over m minus 2 minus m plus 2 over 2m minus 1. So I'm going to distribute this negative. So that's going to be 4m plus 1 over m minus 2. If I distribute this minus to both terms here, because remember this is a grouping symbol, that's going to be plus a negative m minus 2 over 2m minus 1. Okay, so now I'm ready to get a common denominator by multiplying by a convenient form of 1. This denominator is 2m minus 1, so this fraction would need a 2m minus 1. So I'll multiply by 2m minus 1 over 2m minus 1. This fraction has an m minus 2, so this one needs an m minus 2. So I'll multiply by m minus 2 over m minus 2. Now I'm going to distribute FOIL. So that's going to be 8m squared plus 2m minus 4m minus 1. And at this point I'm going to go ahead and do a shortcut. We know we're going to add like terms in the numerator, and we're not going to multiply out the denominator's least common denominator, so I'll just go ahead and save a step. So I FOILed this out. This plus goes right here, and then careful with your negatives. Negative m times m is negative 1m squared. Negative m times negative 2 is positive 2m. Negative 2 times positive m is negative 2m. And negative 2 times negative 2 is positive 4. So now I'm going to add like terms. 8m squared plus a negative 1m squared is 7m squared. 2m minus 4m is negative 2m. And then 2m minus 2m cancels, so we have negative 2m. And then negative 1 plus negative 4 is positive 3 over 2m minus 1 times m minus 2. And then again, we want to check to see if that factors. So I'm going to use the discriminant. So b squared would be 4 minus 4 times a, which is 7, times c, which is 3. And I'm looking for a perfect square here, and I definitely don't have a perfect square. I have a negative under a radical, so that would not factor. And so that's the final answer.